Okay, hi. This is Sloppy Gamedev number 4. Making a game using Claude or the help of Claude. And yeah, let's see where I was last up to. I'm not feeling super motivated today, but I thought it's worth to just try and keep consistency. So let's build the workspace. And then I'll do a little recap of where I got up to last time to refresh my own memory. And then we'll see if we can make some progress. Let me just get to the appropriate code, ratrace.rs. So what we have so far, about 600 lines of Rust. It is, oh no, that was the first one. Then we move to rat race 2. Right. Okay, rat race 2. How much code did we have? A fair bit. 500 lines of code. Right, let's run it. Okay, rat race 2. This was it. Right, so this is a tile map. These are walls. This is a train platform. And this is a flow map, which is the direction that things should flow. I can place agents. These are characters. So this is basically the idea of the game. These are characters that would move, and they're going towards their goal destination, which is the train platform. Now, they all clump together. They don't avoid each other. They don't avoid collision with the walls. So that's something I need to sort out. These little lines that draw the direction of the flow could do with improving. And they're a little bit rigid, so basically, like, they kind of just move at right angles, where potentially some of them you might want to move diagonally. So having that's something that needs to be worked on. And then also then they just all clump, you know. Really what I need to do is have a way for them to say, well, okay, I'm going to wait at the platform for the train, and I'm going to wait in space, you know, so they don't all clump together. So they need some extra kind of logic going on there. Yes, basically. And then what I need to do then is, if they're waiting at the station, oh, that's the wrong thing. How do I delete control? Okay. Agents. So, you know, let's say if we did have them waiting here, then a train would come and they would get on the train and other people would get off the train. So that needs to be added as well. So let's see if Claude can help. Trying to think what we should do first. The way that the flow map is generated, we could probably get some diagonal arrows, I think, by just changing the way that it works. Maybe I'll look at that and I'll ask Claude to do something, and then I can kind of do some stuff on the side. So we are in So in ratrace2.rs, making a train station crowd simulator. There is some stuff that Claude has stashed from its memory, but I'll just give him a bit of background. Currently, when reaching destination, the characters just clump or they're actually called agents. Agents just clump together. We need a hybrid system where they use the flow map, but also apply their own sort of extra, what was it? It's called extra bias, to find a space to wait, and not be too crowded. And let's ask it to do in plan mode. Yeah. Let's see if it can just do that. Right, so that one I'll do. This old thing again. How do I maximize group? Ooh. Okay, I can do that. Right, so Claude's thinking about that. In the meantime, I'm just going to look at some of the code that Claude generated. The flood fill. Update tile editor. Here we go, flood fill. Update flow field. So flood fill neighbors. Okay, yeah, so the neighbors actually we want to go diagonally. It's only doing 4 neighbors. So basically if I drew this out, oops, can I delete a character? No. Oh. I'll ignore that. Let me do some screen drawing. Was it that? How do I enable it? Oh. What was it called? I would have to remember. Just enabling my mouse drawing. Zoom it. Let's get that open. Okay. Right, so basically, yeah, the flood fill algorithm, it's basically checking the flow direction, but it's only looking at neighbors like this. So if you were looking at this square, it's going to check these neighbors, but really we want to also check the diagonal neighbors, and that's going to give a better gradient. So that means just adding them in here, I think. So if we have the cardinal axis, the diagonal ones are going to also be at 1, 1, minus 1, 1, minus 1, minus 1, and which one haven't I got there? Minus 1, minus 1, it's 1 minus 1, I believe, yeah, 1 minus 1. Okay, so let's do that. Let's see what Claude's saying. Unmaximize group. Okay. So Claude has made a plan. Crowd spreading and separation for Rat Race 2 agents. Agents follow the Driska flow field towards the platform tiles and stop there. with no lateral movement force. They all pile onto the same tiles, the ones with the shortest path to the platform. We need peer repulsion, personal space, force, so agents naturally spread out while waiting. 2-pass update inside user agents. Collect all the agent positions in a vec2. Update each agent. Compute a blend of velocity and separation volume, and then move. So that sounds reasonable. Movement blend, yep, okay, so we have separation and flow vector. That's what I wanted. Because there'll be other things like potentially avoiding obstacles that aren't just the other agents. Okay, so new constant, separate. So it loves everything it makes is constants. So the separation radius actually should change based on the kind of the overall density and like how busy the thing is. So if the thing's empty, you know, you're gonna stand away from people with more space. If it's busy, then there's less options. So that's gonna be something that should be more dynamic. Full rewrite of the per agent loop. So this is what's this doing? Update agents. It should be basically you just want to check your neighbors in the same tile as you. Basically, and then that kind of filters the amount of collisions, because there's going to be hopefully tens of thousands of these agents. For each agent, push away from all nearby agents. And blend. So this is wrong. So that's wrong. I think that we want separation radius and strength. So should be dynamic. Be dynamic. Dynamic. Since when the station is busier, the separation radius will decrease and allow it to become more crowded. So that's one thing. Agents should be checking separation based on the grid or nearest nearest neighbors of the grid. I think we need a pass that will group agents, that will sort of bucket agents into grid cells, and then a second pass where we check. Let's have a little look. Let me put an agent down. Right, that's not working. Okay, so the thing is that an agent can actually be, you know, it can be into, well, they're in actually 4 grid cells at any one time. So I think we need a pass where we bucket agents into grid cells, and the second pass we check separation between agents in the same cell or neighboring cells Unless there's a way we can do like a loose, how does it work? Loose octree or loose quadtree is that you only put them in you can only be inside one grid cell based on your position. Maybe I can ask Claude, maybe a way to have a loose yeah, okay, no, a loose grid where we can, I think you can reside in multiple nodes. Check separation between, check separation on a per cell basis and accumulate the separation vector over multiple cells. I think that makes sense. We should also have some randomization and dynamic speed on a per agent basis, just to make it less rigid. Okay. Okay, Claude is thinking. Control K and Control M. Okay, so Drigster flood. Yeah, look, it already worked. I compiled it, and now I have diagonal lines. Which is quite handy. I wonder why that one's not diagonal. Let's put some agents in. So he's going to go diagonally, and so is he. And those ones are going to go straight. I think they seem to move more quickly diagonally, right? Maybe. Is it normalize? This might not normalize the vector. Okay. Okay, so it's saying now it's understand the concept of the grid bucketed spatial lookup, per agent dynamic speed, human agent. It's got some speed scale, wander angle, subtle random bias. Interesting. That sounds decent. Spatial grid. Local to update agents. rebuild each frame. So we have a grid of hash map I32, I32, and a vec3. A vector of vec3. And so in the grid, we put the agent position. I think we should be putting the agent ID, and then we can look up. It's not very good, I don't think, the design of that. Dynamic separation parameters. It's not using the correct structures. Like, you know, we already have the map, which is a grid, right? So then it's made another thing, another data structure that doesn't, you know, we could have flow, we could have density, we could have buckets of things inside a map chunk, right? Not very good from Claude, to be honest. No, like, pretty poor suggestions, I think. So I'm going to have to go back and ask for more. Loose grid. Also register in neighboring cells. So then it has multiple. So, no, poor. Instead of having hash map, for grid, maybe we could use structure of arrays. Map chunk, have a, you know, a vector in each map chunk. It might be the entity ID in the buckets. This way we can actually, you know, apply sort of the forces on the agent instead of just using vec3f positions. Let's see what it says. Oh, and then also we could accumulate agent count into another array. We could accumulate agent count into another array and calculate density. It's annoying that the structure was there of the map, and then what Claude is doing, it just goes, I'm going to make a load of constants and stick those in, and I'm going to make a new thing, like a new structure. It's not doing a very good job at this project in particular. in other things I've had it where it's been doing some cross-platform back-end stuff where it's able to follow a structure that's in place, fill out kind of stubbed functionality. With those cases, it kind of latches onto the existing structure, but with everything I've done so far in this game, it's not been very good at latching onto structure that we can actually build a game out of. It's just, yeah, good point. Map chunk already has density, unused. It's like I put it there for it, you know, to try and give it some structure, to say this is how it should look, and every suggestion it makes is just basically writing completely new data structures with the things in, which is starting to annoy me, to be honest. So let's see what it's suggesting now. Oh god, it's just loads of, right. So map chunk added agent buckets. Agents is a vec of vec per cell. It should just be doing this. It should be a fixed array size of vec of entity. Why does it need the vec3f? Because we can look that up from the entity. Then it's smaller. Mate. Helper methods for agent buckets. Register agent. And it does all the Morton. Okay. They're fine. Pos hash. Update agents. So this is not good. Agents. So it's going to be agents is going to be a vec of entity and that's of array size, so that it follows the convention of the other arrays in the SOA. Okay, so that's one more issue. Also, if we just store entity we can look up the position later using Bevy ECS. This will keep down the storage. There might be some argument to storing the vec3. It's quicker to look it up. But if we're going to have to look up the entity anyway, and we're going to have to apply the force to its vector to move it, we're going to also have to get its position. So it feels like we're going to have to look up sort of entity properties anyway. So we'll keep down the storage. We will need to look up and modify the entity position out of the agent pos anyway when we apply the separation force. So please, I'm going to say, please use the data that is already there. and try and build into the existing structures. You know, we have Bevy ECS for the agents and for rendering positions. And we have the map chunk grid for any like map related stuff. And this is stored in cache friendly local layout to make like nearby sort of lookups make sense. Let's see what it says. This is a lot of talking. So Claude is thinking, is there anything I can do? I find it difficult to just switch between, you know, I thought what I could do is kick off Claude doing stuff and then I can do something, but in a way I'm like, now I'm sort of having to really be hands-on with making sure Claude's doing a good job, or doing the right job. And I think it's going to generate quite a lot of code. Good clarifications. Let me rewrite the plan with correct SOA design. Okay, let's see. Let's see. Okay, vec of entity, SOA. Map chunks, density pressure. That's a bit weird. STD array from FN, vec new. Three-pass rewrite. So we've got loads of constants. It's fucking obsessed with constants. So pass 0, clear buckets and density. Register entities and build the entity pos lookup read only. It's doing it again. It's got another map. What? Hash map entity vec3. Right, but so then we insert that. Then we have total agents. Doesn't look right. It's not done it. Right, it's decided that is going to make agents in the map chunk, but it's not going to use them. Register agent, get agents, get density. So it's got that. But then in update agents, oh yeah, we register an agent. I think this is just too difficult for it. I don't know. So I added the entity pos map, right? And that's how it's getting its position. To get the agent's position. The agent position is stored in Bevy's ECS. You should just be the agent position via Bevy. I mean, this is absolutely a disaster, I think. Like, we've not generated any code. This is like the multiple iteration. I just think it's just going to be stuck in a bit of a rut, you know. Separation, and then scale separation by density, blend with the flow. Another thing that it's not doing, it's just doing X and Z separately. We could be using vec2f. There is a vector class that I'm using, and it's not using it. So again, it's another just annoying. It's not really making use of code. You know, this is easier for it to generate, but it's not easy for a person. You could be doing all of this as vec3f or vec2fs, basically. And like, you know, it's still doing the same amount of arithmetic. It's just a bit easier for a, you know, person to manage, because we don't need 2 lines of this. We only need 1. So again, not you know, this project particularly is not that going that well in terms of what the AI code is generating for me. I think I've had some better results for certain other things, but you know, these are quite complex, abstract things I'm trying to build. You know, and it kind of pushes you towards it in a way that you think it's doing all right, but actually, I think it's... Let's see how it gets on now, right? We have pressure and agents in the structure of arrays. We construct that. That's all good. Spatial helper, register and get agents. That's for looking up based on their grid position. Human agent stuff. Pos hash. Simple hash for per agent randomness. That's just hashed on XZ. Some people might be dropped at the same grid position. So that seems like it's based on grid position. It's not based on individual agent. So it isn't per agent randomness. It's per grid position randomness. Update agents. Here we go. Query. We get the map. Get the indraw. Clear the buckets. Clear all agents. Register entities in spatial grid. So we iterate through the agents. Yes. Register agents in the grid. Register agents in the grid. That's good. Separation. Separation and movement. So for entity in the grid. Okay. Accumulate push from the 3x3 cell neighborhood. I think it's doing this wrong as well. So for each agent, we get the other agents at the tile. Nope, it's done it wrong. So instead of iterating per entity, we should be iterating per grid square. And then we work out the separation for the entity for each grid square that it's in. That'll be more efficient because the entities, we're going to have the list of entities that are here. There is issues with the cache because it's hard to, things are going to move. There may not be local in the cache to each other. But we can go in this grid cell, we iterate over all of the entities, we update them all, and I just don't know if I'm going to be able to get it to get out of this rut. So a few more things. TXs, instead of dealing with TX and TZ and doing maths on, maths 2 times for each axis, it will be better for long-term maintainability to use the maths RS library and use vec2i or vec2f, vec2u, ect, just to minimize the duplication. So that's a change needs making. And then when we apply, what is it? So we accumulate the tiles in the entities into grid. That's cool. Separation and move. Pass 2, separation and move, is algorithmically incorrect. We should iterate per grid cell and apply the separation to each agent of each grid cell, and then accumulate that result for however many cells an agent they're applying the final separation force based on all of its affected grid cells. This has turned... How long have I been going for? This has been going for 45 minutes and we've written 0 code. 0 code. Definitely doesn't feel like 10x to me. But maybe, just maybe, with these changes, with the rework, maybe it can just one-shot it. 2 significant design changes needed. I mean, I didn't specify to it in the first place to use the vector, but, you know, the rest of the code base does use vector. We are using vec3f here, you know. So, it kind of has some hints there that it needs to go to it. It just, at the very last moment, when it needs a vec3f to pass to the function, then it transforms it into one, instead of doing it ahead of time where it might be a bit more efficient. That maximize the group. So, yeah, not really able to do much now, and I feel a little bit restricted. Full of constants. Although the constants should really be more like data-driven, so they could be more dynamic. What can I do something while I'm waiting for Claude? Maybe these ones, I can draw little arrows on it. To make it a little bit clearer on the flow map. Flow deer. Change the colours of them so that they're not black for the negative values. Okay. They're a little bit... kind of hard to see, these ones. But they are a better representation. I might just make them a bit brighter. If we put 0.75, there we go. That. There, we can see the flow a bit more nicely, and they've got colours, and I'm going to put little arrow tips on them. Let me just do this quickly, and then we'll see how Claude's got on. So we've got flow end, flow start, flow end. And we need 2 lines, and then we need the perp of the flow. Perp is going to be we do have perp. It takes a vec2, which is flow dir. Oh. Oh, flow dir is a vec3. Okay. XZ. Okay, so we got XZ, we get the perp. We go to flow end. Well, actually, we go to, say, float end minus flow dir. Don't know what to call this. Oh mate, naming things is hard. Flow end. It's going to be flow end minus. I call it tip, which doesn't actually make sense, but it's going to be flow dir times how big we want that to be. Let's say 0.2. Flow end minus tip plus perp, and that's going to be also times by 0.2. Arrow size. Tip plus perp times arrow size minus tip minus perp times arrow size. Right, so I've added, tips vec3. Oh, this needs to be a vec3. So the way to do it is to make this a vec3. And put y at 0. Well, that hasn't worked. Flow end minus flow dir times arrow size. Perp times arrow size. Oh. Well, I can't even do that now. I'm blaming Claude for rotting my brain. Right, let's see if I can figure it out. So from the flow end to flow end minus tip. Right. It's just tip. And these should disappear now. Come on. Right, they're gone. And then we add a perp and we minus a perp. So we have one on each side. Oh yeah, look at that. Still got it. Maths. I did some maths today. How do I zoom more slowly? Anyway, I've drawn little arrows, so fuck you AI. You You can't replace me. I've done a small amount of maths. Right. Let's see if Claude has stopped being shit. Okay, let's see what he's saying. Claude's plan. Agents follow the disk flow field. Yes. Map chunk gains an SOA of density, and agents, tiles, coordinate use vec2i throughout mass.rs to eliminate duplicated xz arithmetic. Yes, please. Separation is computed per cell, not per agent. Okay, human agent dot sepforce. So agents register in multiple cells via loose grid naturally accumulate stronger forces. That sounds good. Map chunk, we already looked at this. Yep, that was all good. Spatial helpers, clear agents, register agent. So that's basically Morton number for looking up the grid cell positions. We can get an agent and get a density at the desired chunk, which we shouldn't have to be doing lookups, because if we're in the cell, this needs to be optimized as well then, because if we're in the cell, we know the density to look up. We'll have a look how it uses it. Human agent. Separation force, yes, correct. The problem with these are actually, these should be separate components on the entity component system instead of, so the whole thing is structure of arrays, where this is an array of structure. So again, Claude just not really following. Simple hash for per agent randomness, which we've already determined isn't per agent, it's per tile. So again, wrong. But for now, that's fine. We can rewrite it. Here we go. Update agents. Reset the per frame state data. So that sets all of the agents' separation force to 0. I'm going to have to tell it to change that because of the design of the agent is wrong. Register the agents in the spatial grid. That's fine. Per call separation accumulation. So why is it doing this, man? It's gathering unoccupied chunks. Just, like, the memory's there. Work on it in place. Like, what it's doing, it's taking the chunks. Okay, maybe it's fine. To avoid borrow conflict. Okay, maybe we'll let it get off with that. Collect agents in the cell. For each cell agent, so doing unsafe code. Mate, this is a mess. I think this is quite overly complicated. I'm not convinced it's going to work. I also think that I'm going to tell it to change this. Human agent should be not a struct, since we are using the separate fields. Should be components. Then we query, should be components. Human agent would just be an entity flag. that we know it contains, you know, whatever components they have. Pos, speed scale, wander, angle, ect. Then we just query the components we need, which may differ. In different operations. And the sort of component SOA approach is more cache friendly. What a mess this is. This is an absolute disaster. I'm gonna make this a slightly brighter again. I'm pretty happy with my little arrows though. Let's see what we've got. Oh, I'm gonna get a terminal. Basically, oh yeah, there's a couple of things in there. I'm just going to add these before I let Claude make the changes. Add diagonal. Right, so add diagonal neighbors in Jigstra flood fill. Add arrow tips to flow field. Right, I'm pushing that, and then that means at least if Claude makes a right mess of this, we can here we go. Agents, map chunk. Map chunk's good. We got the structure of map chunk sorted. Get density, I need to check on that actually. Update agents. Pos query, set query, move query. Yes, it's separated the update agents, which is cool. What I need to check on is it calling get density a lot? For entity, get density for tile. That's for applying the forces. I think it could change that. But this is taking too long. It's like, this is my problem now. I feel impatient. It's like, really, I need to go back, and I think that density scale could accumulate. No, this is a fine change to make. Because like density scale could accumulate in the second pass, in pass 2, allowing multi-tile density. And then you don't have to continually look up the Morton, since we're working, if we're working inside a tile, we look up the density. Well, we look up the tile index once, and we can fetch any properties directly. Hopefully it should understand that. Mate, this is long. So this has been 1 hour and 5 minutes, and I have not written a line of code. Well, Claude has not written a line of code yet. It's still under control, under plan mode. We're still in plan mode. Good call on both points. Thank you, Claude. Thank you for saying that I'm right. Those ones got accidentally deleted. Look there, and then that updates the flood fill updates when you change the map. So that's quite nice. Okay, let's see. For the millionth time, have we managed to get a plan that's going to work? Agents, okay. Component decomposition, replace a single with separate components. Okay, human agent, agent pos, speed scale, wonder angle, set force, local density. That's cool. Human agent becomes a aggregation of components, which is how you're supposed to do this. Pos hash is deterministic per agent randomness, so it's not. Maybe we'll get it to fix that quickly. Map chunks is an SOA. We kept it that way. Oh yeah, clear agents, all good. Register agents, get density. Get density still smells to me. I'm not sure if we should need it. I think what we should be doing more of is get tile index, and then we can get density, we can get flow, we can get all of these things in like one go. But I think at some point we might have to just go with it, and then we can kind of iteratively sort of refactor it. Bevy will reflect conflicting borrows. If the query sets overlap, we need to consolidate into one wide query and destructure per pass. Pass one reset, register into a grid. That's all good. Per sale separation and density accumulation. Build a snapshot of occupied cells, including pre-computed chunk key and Morton index, so we can access all the chunk arrays properties directly without repeating Morton math. Okay, that sounds good. And then for each occupied cell, 3x3 separation. There's some unsafe code here, which for entity in cell agents, accumulate the cell's density into the agent. Multi-tile sum for loose grid agents. Unique right to density's local density. I guess it's how we're basically getting one at a time. For entity, and then we apply them. This one makes sense. This one, pass 2, seems a bit iffy. in how it's per grid cell, but then we have to query density, we have to query position based on the entity index. I think I'm gonna say let's take it though. Morton decode doesn't currently exist. Pos read sep query. Right, I'm gonna just say let's auto accept. What's the worst that could happen? User approved the plan. So, I mean, this is them so far. They're rigid. They're going to clump together. He's stuck. Ooh. So we need that kind of sort of wall collision as well. That's going to... Yeah, he's got stuck as well. So verification, they'll funnel and spread sideways on the platform. Crowd visibly denser if there's more agents. Agent moves at various speeds. And then if we can get this to work, then you really want a train that's going to come along. And that's going to be full of agents. And they're going to have to get off. And then these ones will have to make room for them as well. So it's actually quite complicated. So... maximize group. There's some stuff like there's this Morton encode, which I already had in my maths library, so that's kind of stuff we could change. Had issues with these tile names, place names, which kind of like the same thing. Just a little bit of... I mean, it took a long time to make this, so I'm not going to be surprised if it takes a while for it to write it, but in the meantime, I'm just going to chill for a bit. I'm not really feeling it today, but I thought it'd be good to just, you know, keep on chugging away at it. really what you want to build is like an exit here where the people come on the train, they come off and they want to go to the exit. So then we need two flow maps, one which goes to the platform and one which goes to the exit. So then you would have multiple flow maps depending on your destinations, and maybe you would use multiple flow maps for the agent depending on where they're going. Because as it gets more complicated, you're going to have multiple directions they can go. So, you know, you could have platform A, platform B, you know, and you might even have waypoints along the way, different lines, so that people will have different lines, and then they'll have the different platforms they want to go to. Let's see, while I'm waiting, I'll have a look at how the token usage is going. Oh, we haven't used that many tokens so far. 24% of my session tokens. I've got a little bit of extra balance as well. But yeah, it's kind of annoying because I would like to do more stuff, but I don't really know what to do, and I don't really want to edit this same file. Maybe I could have a look at this stuff, this editor state. We have place mode, tile or agent. Then we have these wall barriers, escalators. One thing at the moment I am thinking about is that originally I was like, right, I'll make it a 3D grid, because I do want to have, you know, this is going to be an underground station, so you're going to go downstairs and you might have multiple platforms that you're going to have different levels. So these are 3D arrays for the map chunk. But there are some issues with that, because you're not going to really have that much in terms of like 3D elevations. You're going to go between them. So it might be better storing these as 2D dense arrays, and then having like sections like escalators which would join the different levels together. So essentially each grid square in the y-axis would be its own map chunk, and then we'd have another mechanism that can join it together. So that's certainly something to think about. The map chunk, it's certainly, yeah, it would be a 2D array. And then the way we work out a chunk key, XZ. We're actually doing that already, X and Z. Pack chunk coordinates into a 64-bit key. Tiles to chunk. But yeah, I think I'll get it moving, get the kind of get the basic 2D version working, and then start thinking about how to scale it into 3D. It's a lot to think about at first. I'm still sort of, I don't know, slowly wrapping my head around it. Oh no, there's a new instance. Okay, what's it saying now? Write this. So it is writing stuff. The file has been updated since I last read it. 8 directional Jigstra and arrow visualization. Let me write up the updated file, including the... Okay, so... it's doing stuff. It's compiling. Definitely got more code in there. Let's see what we're saying. Vec2 throughout. Okay, that's quite good. So for all of our back and forth, now it's added lots of Vec2 map chunks. So, is it gone in? It's done. Here we go. Here's all of the code that it added. The multipass update agents, clear the spatial grid, register each agent in the spatial grid. This occupied set, the pass 2-bit I'm not keen on, but we can refactor it, and I think the pass, like them being in these passes, kind of makes that possible to focus in. I think this one looks like a normal bevy kind of iteration loop. Draw the agent as an octagon. Was it already an octagon? So now it should be, I mean, it should be doing it. Oh. Well, they've kind of got stuck there. I mean, not what you want to see. Well, well, well. So, now... this guy's kind of stuck. We need some logic for them to... I mean, they kind of dispersed on the platform. This is kind of working in some way, though. It's a little bit crowded. They're getting stuck on the walls, but that's something we can we can sort of resolve next. Right, well, not, I don't know actually. Now it's getting a bit crowded. Let's sort out the getting stuck on the walls is obviously the main problem at the moment. Here, the platform, I'm trying to think about how to deal with that, because really you want them to, I mean, at this case, this is too busy. So yeah, let's try and get them. We need a way to visualize the density or the separation, and maybe ways to enable and disable viewing the flow. But like these are kind of stuck. The like separation forces are probably cancelling out or something. Okay. So the agents are getting stuck. Need extra. So we need an extra force to force them away from walls and into the proper flow. It seems like some of the can cancel one another out. So agents get the ones stuck on the wall have a knock-on other agents. Assuming the separation. I think some debug stuff might help. So say if I mouse over one or some mode, I could get it to show me the separation forces. Can we add some? The grid pressure, the grid density, and per agent separation forces. Let's see if it can get us out of this mess, right? Yeah, like this guy's stuck. He's obviously got separation forces blocked him. So at that point, he needs to go, well, actually, I can go down the middle. My separation radius is too great. There's a weird thing about this, though, that I don't, like, you know, Claude's generated the code, so now I don't really want to edit it myself. And you feel detached from it. So I think that's definitely a problem with generating large amount of code. If you write it all yourself, you kind of like, right, I know where I am, your head's in it. Whereas here, yeah, this separation strengths and stuff, separation density scale. Yeah, the density, place walls, spawn agents. Agents should no longer pin. Yellow sep force line and cello. So we're going to have separation force and wall repulsion as well. It's applied the changes. It's applied some changes. Oh. Well, it hasn't. It's got stuck on the wall straight away. There's a bit of an issue when it's in multiple cells. I think that density grid. Well, he's got stuck. He eventually got away from it, but like it doesn't know where to go properly. Well, for starters, we should just be moving them out of collision, which he eventually has. It's kind of weird. They sort of eventually solve it. themselves. Right, okay, well, all done. Wall repulsion. Does the agent have a radius? So, okay. So we should have so that the radius of agent never intersects with the with a wall or with other agent. So let's just do it for the wall. Actually, they shouldn't be intersecting with a wall. There is still where the wall repulsion was incorrect, and flickering, and the agent was stuck. You know, they should be able to work out, you know, the correct direction to go a bit more robustly. And I also noticed that the multiple flow vector from, you know, multiple grid squares can sometimes sort of fight maybe we just pick a single flow dir based on position, not radius. Let's put it into plan mode. See, like there, like why is it kind of gliding? It was like it's in multiple squares at once, and then I mean it kind of should just be averaging. I mean, they do make it to the destination, but it just feels really horrible. Look at that. It's like it's kind of sticky. It's the separation dir. Actually, I'm just going to put it. Actually, I think it was separation dir was causing to be stuck on a wall. Where we need more sort of bias, like separation dir since the radius is large, this should take until it gets, you know, really critical. Maybe. Right, so, but even on their own, right, this guy, the movement doesn't feel like, why is that? Like, that doesn't feel smooth. It also intersects with the wall. We should have a collision. But it now, they are avoiding the wall, at least. With a better collision, that would not happen. And so at least we have fixed one thing. They don't get stuck on the wall anymore. The movement feels like crap. Absolute crap. And really, this density visualization is horrible. But it does indicate some issues. The flickeriness. Now it has the full context. Separation priority. And like the thing was the separation radius, was that dynamic? It should be dynamic. Huh. And then even like, so then once you've got it, basically that it's quite unstable, you know. Look at this. Let's take their changes. It's failing to compile. Pass 0, clear the agents, pass 1, register the agent. It's only doing it into a single tile now. For each occupied cell, we collect, and then accumulate separation from 3x3 neighborhood, which makes sense. It's just put these kind of debug things inside the same, function as the update agents, instead of really separating them out. So there's also that aspect of it. The code it's generating, it's not really structured. We're drawing the agent in the update agents. They should be decoupled. Mouse hover for the force visualization. Should also, right, reload has completed, so right, agents. The collision is totally wrong. Look at that. Oh my god. Right. Collision radius is totally wrong. The hard push out. Agent is an octagon. Collision is totally wrong. The radius. Entity. I mean, look at this. Terrible. This is basic collision detection. So it detects the collision at the wrong point because it hadn't intersected, and plus it's moving it back like double, even more than that. Penetration formula is inverted. And also I don't think I like this code at all. Can move. getting on for 2 hours. I think 2 hours is enough of this. I'm getting thirsty and tired. But we'll see if we can get Claude to fix it before pass through push out block. I can't be bothered reading it. Let's see. I think that the way that it's doing it, let's see if this fixes it anyway. So, it says it's done it. Oh, we have reloaded agent. Right, now he's stuck. Not great, not great. So now the issue is that it's treating these two cases, right? I think it's face by face, so it's only doing one. Discrete one face. Edge case. When we slide to the corner, we can intersect as we sort of reach. Let's see, how did it do it? We can intersect as we reach the center of the agent. So let's see if I can describe this. Intersect the wall. If we slide the x-axis, we can hit the corner and intersect over the z-axis. Sometimes bouncing, wobbling, sometimes bouncing back and forth. We should treat the collision of multiple axes for smooth handling of corners. Oh my god, Claude. It's done. I don't know. How are we doing? Yeah, if we can fix that, the smoothness, the wall repulsion thing, like, you know, depending on density, like you know, we want to have, this is the next thing I have to work out, I think, the density control. Once I just get this, try and iron out some of these sort of smoothness. And these are all a bit jittery. I think like they should try and settle instead of, I don't know, they don't actually look jittery though, do they? There's some jitteriness going on. We want it to be stable when things are waiting or queuing. So that's one thing. Stability. And then general smoothness. Like, I don't know, it's getting a bit better. They are making it. We want the collision with each other and the collision with the wall to be better. Let's see. 8 neighbor AABB loop. What are you on about, mate? Replace the 4-direction face normal loop with an 8 neighbor AABB loop. Checks all 8 neighbors. Discovers diagonal tiles. Oh, is it because they're... I see. So if we're here, where we technically were, when we were we check this one. Okay, so that sounds reasonable, but also annoying. Only fire when the circle overlaps a tile AABB. Okay, let's go for it. I think it's figured it out, but... Okay, it's saying that it's done it. So let's have a look. Okay, he kind of did. He went a bit slower when he was going around the corner. So I think we want to... they're stuck on the corners. Let's see if we can get him to fix this then. Did I lose it? Oh no. I closed it. Okay. That's improved it. They no longer intersect, but they can get stuck. And they move more slowly. Can we transfer the velocity? and sort of use the flow map to sort of force it. Right, that's over 2 hours. I think the last session I did was about they've been all about 2 hours, so I'm going to be thinking about wrapping this up. If I can get it to the position where if they don't get stuck and they're able to move through, I think that would be nice. See there, you can kind of, the other ones can push them along. But also I think we want to have a hard collision so that we resolve any collisions where we have overlapping agents. And that needs to be kind of like an iterative solver, because they should push each other and spill out if the density becomes too high. Then there's stuff to think about scaling, stability. You don't want this jitteriness. Yes, project the velocity along the wall. Of course. That's how you do collision detection, mate. You figured it out. Well done. So then, yeah, we want to have an iterative collision. Here we go. Let's see. Oh. Agents. Still stuck. It eventually did. So it eventually resolves itself, but it's not. It's sort of. Let's see what we can do. As the Oh my god. So we eventually get sorted, which I suppose I suppose that's better than nothing. They get stuck and they overlap with each other. They shouldn't do. Oh no, two of them have got stuck now though. It's like they, between each other, they're going between that direction and this direction. It's not doing it, mate. It's still the same. Needs to be still stuck on corner. Now we're just in a death loop. I think that you need some better mechanism. So like, you know, what it's doing is selecting this tile and it's getting that vector. And then it's selecting this tile and it's getting that vector. Really, we could get both, and then we're going to get a slightly in between vector, which would be this way. If we push him that way a little bit, then it's gonna at least, if it does one frame of that, I think it needs to be pushing it out based on the corners. Like, instead of doing it per axis, it needs to do it for both. It's going to intersect both axes when it moves. So I think you need a bit of movement in both axes instead of doing one at a time. Still stuck on corner. Let's have a look. I think I'm not happy with this collision. I'm not happy with any of the code really that Claude's done here. If you don't know what you're doing, you'd be like, oh, it's making a game. Well, it's making a shite game. And it's doing a terrible job of it. So, yeah. Fuck you, AI hype boys. You're all cunts. So, circle versus AABB push out. Same bounding circle. So, right, so if tile is a wall, yes, this is it. Sum of the wall. So it's saying it's done it now. Clean. The escape velocity is combined with wall away direction. Projected on both axes. Okay. Let's see. Has it done it? No. It's not done it. And if there's two, they block each other. So single agent, corner feels sticky. They do eventually. Two agents can be placed on corners. In different tiles. So we've got, can we do a little diagram for it? A, B, C. There's two gaps between. Where A and C are stuck. And if I indicate it like this, edge. I think the it doesn't. I don't know if it is that or it's just. This is annoying. I wanted to stop by now. No. Single agent can get... But it feels sticky and horrible. They need smoother and no lost velocity. I think two agents stuck on adjacent, on opposite corners of a corridor opening each other to deadlock. It's doing an absolutely shit job. Claude is doing a shit job here. I'm not happy with it. I'm not happy with the code. I've done collision detection myself a million times. There's so much better ways, but somehow I'm trapped in this loop of trying to get Claude to do it. I suppose this is the purpose of this series, to try and do AI slop generated game dev. And oh my, this is slop if ever I've seen it. We want smooth, continuous collision, and then we get basically, I think we want to have the flow. We want to obtain flow from multiple grid squares, because that would get, technically it would get 3 of them, 1 of them, and then a collision with a wall. So let's give Claude a last chance. Let me check my token usage. 91% used, so this is getting towards the end. 2 hours, almost 2.5 hours. Draw agents. What do we have? We've got separation force yellow, flow direction cyan. Yeah, the flow direction is flickering. I think we want to take multiple flow direction. Okay, so it's saying it's going to preserve the velocity. Let's see. It's not done it. It's not, nothing's changed. No good. No, all your recent. So this is where I'm going to get annoyed at it. When it is stuck, it is flickering the flow map direction of let's say -1, -1, and -1, 0. It needs -1 to move away from the wall. See if I can get it to sort this out. On the token limit now, 91% used. Oh, 96%. Not happy with this session at all. Not happy with Claude. Not happy with anything. You can say it's a skill issue or not, but I actually know how to do these things without it. And it's very frustrating to just see it failing and to have to parse its stupid code that it's generated. Look, you know, it's doing this again. It's doing distance squared. There is ways to do this in the maths library. I told it before, use the maths library. But no, it just keeps writing everything out. So I've got all of its shit code that it's generated that I don't want to have to work with or deal with. Look, separate XZ. You know, despite me telling it earlier, use the fucking maths library. Suppose the diagonals do cause it. The flow map could probably solve it, actually. Accomplishing. Are you really? Are you really? The flow map definitely doesn't help on the corner side of things. And here I think then they're blocking one another. Okay, the problem is clear. Come on. That was better. But it's still sticky. Yeah, they affect each other a little bit, but I think... Well, let's see. They're not getting stuck as badly now. A little bit of clumping. I mean, it just feels a bit meh, really, in general. Ooh, we've made these shitty little things move. I'm underwhelmed by the whole thing, but progress has been made. Gonna call it there. They are working. It is kind of working. Right. Okay. And the corner thing, we can have a bigger radius and stuff like that. To kind of... you know, people aren't going to go that close to a wall unless they really need to. And that all of that radius based on distance and density and stuff. So we'll call it a day there. That has been an ordeal. Let's check this out. Here's all the changes we made. Anyway, more than that, I'm going to just add this to Git. This is on GitHub. Check out my engine hotline on GitHub. Sorry for getting annoyed. Claude did get there in the end. Still not so super happy with some of the things. But progress nonetheless. And slow and steady progress, maybe we will get to something that is usable. So what's this going to be? Wall sort of wall avoidance and separation forces. And that is going to be it. I'm going to call it a day. This has been sloppy game dev, and this one has been very sloppy. Part 4. Let's see if we can get some progress next time. This has been 2.5 hours, and time for me to stop.